So yeah, I'm just going to be, I know this is a technical forum, so I'm just going to give you the quick spiel. Don't worry, I won't be up here too long. But what I do want to explain is why you're here at all today and why there is such a thing as DNA and why Cisco has done what it's done with its architecture. Because you're here today to learn about DNA, and that is not a tweak to the way we provide networks. It's it's a radical transformation of the whole networking architecture. You're not here to learn about some boxes that are a bit faster or some better speeds and feeds. It's about a completely different way of providing a network. Now, why have we had to do that? Well, to give you a sort of an analogy, an explanation, let's just think that any one of us in this room right now could walk out into the high street, we could buy a phone, a new phone, we could download an app, we could configure the app to our own needs, and we could start using the app by about 10 a.m. Now, however, let's think about if your business wanted to introduce a new app for its business, and with an increase in digitization, and we can talk more about that later, they are going to want to do that more and more. For you to be able to implement a new application in the business, you're not going to be able to do that by 10 a.m. That's going to take weeks with the current networking technologies that we have. How many of you, for example, have a managed service on your routing network, on your WAN? Managed WANs? And how many of you find that if you want to either introduce a new application to your MPLS, to your QoS, or if you want to change the priority of that application, can take weeks to get that done? And how many of you therefore don't bother to do it because it's going to take weeks to do it? We've got 3,800 features in the Catalyst 6K switch alone. How many of you have activated all those features? Nobody, because to do so, you'd have to log into every switch in your network and you'd have to do tens of commands, even more of CLI commands to be able to activate it. And if tomorrow you changed your mind about one of those features, one of those configs, you'd have to log in and you'd have to do it all again. And so it's too lengthy to be done. Now, this situation has become so bad that Gartner have come up with something called bimodal IT. Who's heard of bimodal IT? So bimodal IT is the thing that Gartner have come up with that some customers are having to do, and it's basically to implement two IT infrastructures in parallel. One IT infrastructure and architecture is for reliability and security. It's for all the stuff that we've always done that our business is reliant upon. And then there's an implementation of a whole different infrastructure, mode 2, which is for agility. That's the one the DevOps are using. That's the one where we're trialing new stuff that we want to get out to the business quickly. Now, the last thing I want you to take away from this is that a Cisco director says that networks are slow. That's not what I'm saying. The boxes themselves are very fast. They're not the problem. But you've got to admit that when a customer is having to deploy two IT networks at once, one for reliability and stability, and another one for agility, there is something up with IT. That's just not sustainable. So for that reason, the industry, and Cisco in particular, has transformed the way we provide networks. Now, notice I say we've transformed the way we provide networks, not we've changed the way we provide networks. Change is what you get when you look at a problem like the one I've just described, and you think of some new solutions. So you might think, how do we make it faster to implement a feature on a switch? How do we make it less lines of CLI command? How do we implement these things a little bit quicker on the router? But we haven't changed, we've transformed. Transformation is what you get when you look at a problem like the one I've described, and you don't try and apply new solutions. You ask completely different questions. So you don't ask, how do we make it faster to implement a feature on a router? You ask, why do we need a router at all? Why don't we decouple that software that's on the router, those features that you want to implement? Why don't we decouple that from the control function of the router? And why don't we put it on a server? Because we all know we can deploy a server like that. And that is where we've come up with something called a virtualized network. You're going to hear about it today. It's called ENFE, where you won't necessarily need a router anymore. Or if you do, you'll at least have decoupled the software and the functionality from it. We looked at the ways of orchestrating networks. So rather than asking, how do we make it less CLI so that you can implement these features, we said, why does anybody need to do anything at all? Why doesn't the network orchestrate itself? Why can't it implement things itself? And that's where we came out with an automated network. And you're going to hear about something called the APIC-EM today. And the APIC-EM has applications on it that you tell the APIC-EM once what you want all those switches to do, and the APIC-EM automates that in the network for you, so you don't have to do that anymore. Then we looked at, okay, when we've made the network this clever, why don't we actually give some of that intelligence back to the business? So IT isn't just known sometimes as the bottleneck, and we're not just the person providing the platform, we're actually giving business intelligence. And we're doing that with analytics. So we're actually able to look at analytics information that the network sees, because the network is the one element that sees everything that goes on in your business. It connects your people and your devices and what applications are being used, and how long they're being used for, and what is being done that shouldn't, and what security breaches are you having that you shouldn't. The only thing that knows all of that is the network. So why don't we use the analysis from that network to start giving you some intelligence for the business to use? And that's where you might have heard of things like CMX. CMX is the Cisco technology that can be deployed, for example, in museums or in large shopping centres or malls, where when you walk into the mall, the analytics on the network sees you walk into the mall because you've got a wireless device on you, and can then give back to that shop or to that museum the information of where you went when you were in the mall, what you bought when you were in there, what picture did you look at when you were in the museum, how can they sell you more goodies from the gift shop. This is the kind of intelligence that the network provides to the business. We've also got that in the data center. So you'll see that Cisco acquired a company called Tetration, and it does exactly the same thing. Sensors in the network, sensor in the elements of the data center that can then analyze what virtual machines are being used, what applications are being used, what resources in the data center are being used. And it gives you that analysis, it gives you that network information so that you can set your policies based upon what's actually happening, because right now it's all a bit of a black hole. So the analytics of the network as well is something where we give you information from that network because we're the only ones that know it. So this is the slide that you're going to see lots today, and it basically describes what I've just said. This virtualized network, which is something called ENFE, you're going to hear lots about that. This automated network where the APKM and applications upon it can actually automate what it is you want to do with that network, the analytics that's provided. And of course, you're going to get cloud-based, so much application development and so much of the workload that you have. 42% of our workload will be done in the data center, according to Gartner, by 2020. So we have to make sure that we're enabling that and that we're working with that. And we've got apps, and that we're supporting you having your apps and your control in the cloud, even though it's for things that's going on in the branch. Open APIs. Why did we assume that all the functionality you would have in your network was functionality that was developed by Cisco? Let's say you're a shop, and let's say you want to do analytics that says, when a teenager walks in, you want to know that a teenager's walked into your shop so that you can promote Abercrombie and Fitch sweatshirts, let's say. Cisco is never going to write you an app, I'm fairly confident. We're never going to write you an app that tells you that the network will tell you when a teenager walks into your branch, okay? But a retailer might want to know that. But who says it has to be Cisco? What if you write that app yourself? What if your DevOps team write that? What if a third-party company writes that? So we've enabled that with open APIs so that more and more functionality over time that you will want in your network can be created, but can then be enforced by the Cisco network. And of course, it all has to be open and programmable, because as the world is moving forward towards this digitized network, we've really got to make sure that we're open to that. Just on the subject of digitization, because it is the digital-ready network, to really explain digitization, because an awful lot of things get shoehorned into digitization. But digitization is truly the automation of a business process using technology. And I just want to explain that and have that at your top of mind as you're thinking about that today. Because again, this isn't about networks only providing connectivity. As our customers regularly and more regularly start to automate their business processes using the technology that we provide and support here in IT, we're going to see increasing demands on the network. I will give you an example of what's true digitization. How many of you in your time have had a parking ticket? A lot, everybody probably. And it was probably put on your windscreen by a man or a woman, a traffic warden. But now, here in Westminster, we're connecting parking meters to the internet. In Russia, 15,000 parking meters have already been connected to the internet, many also in Birmingham. Because when you connect the parking meter to the internet and you connect your parking attendant to the internet, then when you connect your car to the internet and the parking meter to the internet, you don't need a parking attendant anymore. What you've done is you've digitized that process of giving you a ticket, because it will happen automatically, the internet will do it. That is true digitization of a business process, and that is a business process that is being digitized right now here in Westminster. There are many, many more examples, and I want to get that to your top of mind, because to be thinking about the digitization of your business processes in your business that will be happening. Because increasingly, as you are digitizing those business processes, more and more of those business applications are going to be virtualized down in your branch. They're going to be on a server in your branch. And so why not have your networking functionality virtualized and also on that server, also in the branch, so that you can start to get more intelligence between the two. And that's another key reason why we've come up with virtualization. This isn't in isolation. This is a network to prepare you for this absolute, torrential expectation that we have of growth in digitization. So that explains what the architecture is. You're going to see this slide many times today, and you're going to hear much more about all of those different boxes and what technologies we've got in them. But overall, that gives you the summary of what's DNA and why Cisco has had to or wanted to develop it and innovate in that space. Thank you.